This is the lecture 2. We should talk about the Python um, and then computational thinking and computational uh, problems, and then we'll talk about the complexity analysis using the asymptotic performance and the big O notation using big O notation, and we talk about the analysis of the algorithms. In order to use actually the Python, you can simply use the Learn Python here, the learnpython.org. This is very good interactive tool. It's online. You can write the Python code there, and if you have problem with some IDEs or you're not able to install the IDE, conducted twice a week. We go back again. Just before I proceed, uh, I would like to just remind you that for this course, this is a weekly course. So during the summer, this course will be conducted twice a week. So our class will be every Monday and Wednesday at the same time from 8 to 10. Type. For the second part, this is the lecture 2. We should talk about the Python and then computational thinking and computational problems, and then we'll talk about the complexity analysis using the asymptotic performance and the big O notation using big O notation, and we talk about the analysis of the algorithms. In order to use actually the Python, you can simply use the Learn Python here, the learnpython.org. This is very good interactive tool. It's online. You can write the Python code there, and if you have problem with some IDEs or you're not able to install the IDE in your machine. And here are some of the useful, very useful actually resources for interactive tutorials. They are free, open course, so you can use it for self-learning. Also, these books are very helpful. This is actually similar to the books that I have highlighted in the previous part. And we have some videos here and tutorials on Python. You can go through it one by one. Here is just a summary on the most important features, attractive features of Python. They are no compilation or linking. They don't care about declaration. And I think since all of you have already covered this course before, so you should be familiar on يعني the power of Python compared to other courses. Other programming languages. And in terms of the comparison with other programming languages, you can see that compared to Perl and JavaScript and Visual Basic, Python is much better in terms of performance, in terms of design, and supporting enterprises. For the IDE, the one that you use for Python, you can use the IDLE. This is for Windows. Also Emacs with Python, and Eclipse with PyDev. This is also IDE that can be used for writing Python codes. And if you don't want to install any uh, IDE in your machine, you can just simply use this online interactive tool for writing code. طيب. Starting with the first question. What is computation? What do you mean by computation? Yani, I want you to try to think about the meaning of computation before give me the definition. I'm not looking for formal definition. I wanted your own word. What do you think about computation? What do you mean by computation? computation بالعربي اللي هي الحساب صح؟ computation اللي هي الحساب. So what do you mean by computation? يعني انت in computer science, what do you mean by computation? When do we perform computation? It can be mathematical calculation, حساب سرعة, Sonia, think I will come to this point. Manipulation, finding results. Okay. Fine. Right. When it comes to computation, okay. When it comes to computation, it is not necessary to be carried out on computer. Computation as a computation, see, I'm talking about general term, computation. You can do computations on papers. So computation, it is not related to computers. Okay? But we use the computer to think and perform some computations for us. To think and compute for us. But it is not always related to computer. What we care of here is how the computer is going to think for us. How the computer will help us to do the computation. No, manipulation, Nusayba, I think yes, Nusayba, manipulation, it can be part of the computation, but it's not a computation. It can be part of. So, here we are going to focus on two problems or two terms: the computational thinking and computational problems that are related to computer. So we'll talk about computational thinking, how you think in computational way, and we are going to talk about the problems from the computational way. So computational thinking, computational problem. Janet Wing, she's a professor in America in the Carnegie Mellon University in US. She said, actually in one of the interviews, she said one can major, okay, like finish, complete the study in computer science and do anything, okay, and do anything. One can major in English or mathematics and go on to a multitude of different careers. One can major in computer science and go on to a career in medicine, law, business, politics, any type of science of engineering and even the art. That is actually summarizing the power of computer science. Why? Because it gives you the power of critical thinking and problem solving. Again, I back to this point. So, you can see some successful people who are working in politics, but when you go back to their background, educational background, they are a computer science. يعني احنا بنشوف بعض الناس اللي بيشتغلوا في السياسة، اللي بيشتغلوا في الطب، حتى في الميديسن. Even sometimes in medicine, if you look at their background, they are in computer science. In law, why? They are actually building their skills, they are developing their logical skills. Even in management, in business, you can see the top of the good companies across the world. Look at the top companies across the world, like Google, it's a company, right? Facebook, it's a company. Microsoft, it's a company. The head of these companies, they didn't study management, they study computer. So it's not a matter of what you study, it's a matter of how good you are in logic and problem solving. So if you are good in computer science, you can work in any area. You can get a job in any other areas, not only in computer science, not only as a programmer. You will be successful in different type of sciences. So what do you mean by computational thinking and computational problem? Computational thinking as not merely knowing how to use an algorithm or data structure, but when faced with a problem, to be able to analyze it with the techniques and skills that computer science puts at our disposal. So you might have a problem, you might face a problem that you never faced before. But because you have skills in computer science, you can use these skills from the computer science to solve this problem. So that is how to think. That's computational thinking. How to think to solve a problem using your skills. But this problem you have not faced it before. Where is the trick here? If the problem you faced it before, then you already have the solution. So very easy to apply the solution on the problem. What if you are facing a problem for the first time in your life? You never faced it before. That is the challenge. We are teaching you here, we are teaching you at the university level to make you or to prepare you for this kind of challenges. We cannot cover all types of problems. So we are teaching you how to think when you face a problem. So computational thinking is when you face a problem that you have never faced before and you use your skills that you have learned in computer science to solve this problem. فهي just in Arabic. Computational thinking هي لما أنا أواجه مشكلة، هاي المشكلة أنا ما واجهتها من قبل، لكن أنا في عندي skills تعلمتها في الكمبيوتر ساينس، هاي السكيلز أنا بستخدمها I use it again لحتى أحل هاي المشكلة. So computational problem is described as a problem that is expressed sufficiently precisely that is possible to attempt to build an algorithm to solve it. يعني computational problem, it's a problem, just a normal problem, but this problem is well explained, well analyzed, so you can you can build a problem to solve it. So here it's a solution. It's understanding a problem properly. See, if you have a problem, if you face a problem, and you are not understanding the problem very well. You might prepare and build a solution or an algorithm for this problem, but the solution is not solving the problem. Why? Because you are not understanding the problem very well. So, if you have a problem, computational problem means it's described as a problem, but that problem can be analyzed and understood very well so you can build an algorithm to solve it. This actually the meaning of the explanation of these two terms. So, computational thinking, see, it's a problem that we have never faced before, right? We have never faced before, and we try to use our skills in computer science to solve it. So, if you want to understand what computational thinking means exactly, we need to start from the physical world. We are starting from here. This is the physical world problem. Yani you are facing a problem, a real problem. Now we are facing problem, for example, with the corona, right? Okay, we need to find a solution, otherwise we will sit at home. That's why we come up with the online or distance learning. Yes, we already use it for a long time in Arab Open University, but for some universities, it was the first time for them to use the distance learning and e-learning. So here we have a problem from the real world. What do we have to do? First, you have to convert this problem into a mathematical problem or mathematical model. And then after that, I will automate this mathematical model and build a computer algorithm. So here is the solution. Here is the algorithm. In this part is the algorithm. This kind of algorithms will help us to tell us more about the physical world. I will tell you what. In I think 1990 or 1989, before the Gulf War, the United States, before they start the war with Iraq, they have built a model which can tell them more about whether they are going to lose or win the war. So before they go to the war, they do some simulation. Okay, they do some simulation to know whether, and it's used everywhere. So they are doing simulation to know whether they're going to pass or fail this kind of war. So they have the physical world problem. They have problem with a country. What they do, they build a mathematical model. Mathematical model means they have to know how many airplanes, how many soldiers they have in the army, what places they are located, what kind of equipments, military equipments they have, helicopters, whatever. So these are models. These are mathematical model by numbers. After that, they will build an algorithm, a simulation to check based on these numbers and the mathematical models that we have here. Are we going, if we take action A, B, C, are we going to win or lose? So it tells us more about the real world. So if you have a problem, find the mathematical model, build an algorithm to solve it, and it's called automation, and then it's a cycle. It will tell you more about the real world. That's why it's called modeling, اللي هي النمذجة. So here is the computational problem at this side. لا طبعا يا فاطمة، أكيد لا. يعني إحنا النتائج السيميوليشن عادة بتكون يعني فيها نسبة خطأ طبعا. فيها نسبة خطأ بناء على الارجيومنت، بناء على الباراميترز اللي احنا بندخلها. احنا بندخل معطيات، في بعض الأحيان المعطيات بتكون غير دقيقة، فالنتائج بتصبح كلها غير دقيقة. طيب. So for the analysis of the algorithm, any type of algorithm is actually designed and developed to solve a problem. احنا بحاجة تصميم وبناء algorithm لحتى نحل مشكلة. So to solve a problem we need input, and the solution of the problem is the output. The solution of the algorithm is the output. So if you want to analyze the algorithm, you should look at this part. Okay? The algorithm itself, not the input nor the output. We need to use the input and output to verify the correctness of the algorithm. يعني فلنفرض ان انا طلبت منكم تعملوا لي calculator, develop calculator. انا بستخدم الانبوت لحتى اتحقق من الكالكوليتر. يعني انا مش اكتب 5 زائد 5 يعطيني 15. فانا I'm using الانبوت to verify the correctness and the output also to verify the correctness of the algorithm. هلا after I verify the correctness of the algorithm, I will go to analyze the performance of the algorithm. If I ask you to develop a calculator and I entered 5 plus 5, then I have to wait for 5 minutes to get the result. Do you think that this is an efficient algorithm? To wait just 5 minutes to get the result of 5 plus 5? Yeah, definitely no. That is the important. Remember, we are studying this course to design correct, efficient. طيب. يعني في story, I have a story. I read it in one of the books. In one country in Africa, there was a company. The company has two locations. The distance between the two locations was around, I think, 2 or 3 kilometers. Okay, so the internet speed at that time was very, very low. So the company want to use the internet to transfer the data from location 1 to location 2. So when they send, for example, 1 giga or sorry, 500 megabyte, it takes around, for example, 30 minutes. And if they send 1 giga, it will take around 60 minutes. If they send 2 giga, it will take around 90 minutes, and so on. But they have another way of moving data. They said, okay, instead, because the internet is very slow, so if I want to send 1 giga, I have to wait for 60 minutes. So why I don't hire a person? I will copy the data on a flash drive and then give it to him, and he will walk to the other location, and he can يعني reach faster, right? He can reach the other location faster than the internet. So they find that if that person want to transfer 500 megabytes from location A to location B, it will take from him 60 minutes. And if he want to transfer 2 gigabyte using the flash drive, it will again take from him 60 minutes. If he want to transfer 4 gigabyte, it will take from him 60 minutes. Why? Because he's not carrying the data, the real data, as a heavy weight. So it's a virtual data stored in flash drive. So the time that's going to be taken from A to B is the same, regardless the data that is moving. So now the company is stuck. Shall we use the internet, or we should use the person to transfer data? Based on this story, what do you think? What is the best solution? Shall we use the internet, or shall we use the person for transferring the data? And in both cases, please give me your explanation why you decided to choose one of these. طيب, your answers, okay, your answers are almost close to each other from my side. Uh, they are all logical, but that is not the purpose of giving you this or introducing this story for you. The purpose actually is that for the first impression, when I tell you that sending 2 giga, it will take 60 minutes by internet, and it will take, for example, 30 minutes using the person, it might give you indication that the person is much faster. But what you all agree on is that the size of the data makes the decision. So when it comes to small data, sending small data, the internet is much faster. And when you send large or huge amount of data, then the person is much better. Bear in mind that even sending the data using flash drive with a person has some limitations, because the capacity of the flash drive is limited. Yani somebody might say, okay, he can buy 2, 3, 4, 5 flash drive, still the capacity is limited. So the point here is that to decide which solution is better is based on the size of the data. Okay, the size of the data that we are considering, and that's called the input size. If I tell you that I'm going to send 10 megabyte, which solution is better? The internet. Type. If I tell you that I'm going to transfer 1 gigabyte, لا, they're both the same, right? No, because 1 gigabyte takes 60 minutes by both sides. They are the same. Okay, if I tell you I want to send 4 gigabyte, the person. No, 1 giga takes 60 minutes. Yeah, so if I want to save 4 gigabytes, then the person become better. So with small data, internet was best choice. With average size data, both of them satisfying. But if huge data, then the person is much better. So here we have different cases. The best case is when the small or the size of the input is very small. The worst case if you have a huge amount of data, and the average case if you have average size of data. So for every single solution, we have 3 cases to be considered: best case, average case, and worst case. And if you want to analyze the algorithm, you cannot rely on the best case, right? You cannot rely on best case. And it's very hard to find the average case because you need to find apply different techniques in probability, in mathematics, to find what is the average case. But they're very simple to consider the worst case. And even in your life, if you want to take an action, I think you take the action based on the worst case, right? يعني احنا لو انت بتفكر في حياتك تاخذ اي قرار، فانت ما بتقرر بناء على الكيس المثالية، انت بتقرر على اسوأ خيارات. لانه الحالة المثالية ممكن سهل انك يعني توقع منها، يعني it might not success at all. So if you want to decide in your personal life, actually you are deciding based on the worst case. Even when you register for this summer semester, you are actually deciding to register based on the worst case. Yani you are happy because it's online, right? You are happy because it's online. You are happy to register this semester because the assessments, type of assessments, because it's distance online assessments as well. But you were thinking that what happened if suddenly we back again and we have to take our exams in the campus, and you have 16 hours. Yes, yes, and that is I think this is a nightmare. This is a nightmare for most of you. So you should consider this. You should consider this. We might call you for the final exam to be in the campus. What you will do? That is the worst case. I think this kind of examples will stick forever. Okay. Yes. Yes, Hussein, yes. Of course, you should think about, because this is the worst case. I think you have think about it. Okay, what if they call us? Yeah, you see, she will drop it. Yeah, this is in the worst case. In the worst case, you drop the course. I don't know. I don't know. Might be. Might be. I'm not sure. I will let this worst case stay with you for a longer time. طيب. طيب. So that is actually the meaning of average case, worst case, and best case. And if we want, just remember this please, if we want to decide which algorithm is best, you have to analyze it based on the worst case, not the best case nor the average case. طيب, why somebody might say, okay, I don't think you need to make it complicated. If you have an algorithm, just compute how much time it needs to complete, I mean to run the algorithm, and the faster is the best. That's it, right? Yani if I give you an algorithm and I ask you to check and give me your opinion about it, you will just run it in your machine, find the time. If it take less time, you will tell me it's very good algorithm. If it takes long time, then you will tell me this is a bad algorithm. That is actually one of the worst way of analyzing algorithm, based on the speed. We don't analyze and measure the performance of the algorithms based on the speed. Why? For many reasons. One of the reason is, yeah, the complexity, this is what we need, but time is not a complexity. Time, the processing time is not a complexity. The complexity is something else. We'll talk about it. But processing time is not a complexity. It's not considered as type of measurements. It's a measurement actually, but we don't consider it in analysis. Why? Because if I give you algorithm A, I ask you to run it in your machine, and your machine is Core i7 with 16 gigabyte RAM. You might complete, I mean, algorithm might finish its task within 3 milliseconds. You will tell me this is great algorithm. But if you give it for someone else who has, for example, Core i3 and 2 gigabyte of RAM, it might take from him 2 minutes. So he will tell me this is a bad algorithm. So the performance of the algorithm here relies on the hardware that you have in your machine, and that is not true. We need actually, yes, Rawan, yes, you're right. Based on the complexity, not in the performance, the speed. Because the speed and the performance of the algorithm is actually associated with different factors, hardware factors. So what we need in the analysis is to exclude the hardware factors in our analysis, not to consider the hardware. So regardless whether you have Windows, you have Linux, you have 2 gig RAM, you have 16 gig RAM, we should analyze our algorithm away from the hardware factors. I tell you one thing, you might run a program in your machine, check the time. Now, it might take 1 minute. Check it after 5 hours, it might take 1.5 in the same machine. Why? Because you might be running different applications at the same time. They are all consuming your memory and the CPU. So it becomes slower. Restart your machine, run the program again, it might be much faster. Why? Because the memory is still clear and fresh. So we don't consider analyzing and comparing algorithm based on speed. It's only based on complexity. So today, inshallah, we are going to proceed from this point. Actually, this is the second part of meeting 2. This is the second part of meeting 2. I have already posted the first part of meeting 1 in on LMS. I hope you could يعني download it. Now we will proceed from this point, which will talk about the complexity of the code of the algorithms. Now, before we start, I think okay. I think some students they have problem with the sound. Just not to interrupt the meeting. If anybody has any problem from your colleagues, just please one of you reply him to leave the meeting and log in again. طيب. So we started in the previous class. I would like to go back one slide. We talk about the how to examine and analyze the performance of the algorithms, and we say that uh, we cannot rely on the time analysis because the time may vary from one machine to another. يعني احنا بصير في اختلاف التايم، ما بنقدر ان نعتمد على التايم فقط في حساب كفاءة وفاعلية الالجوريثم. السبب انه التايم دائما بيكون مرتبط بعدة عوامل اخرى، منها سرعة الرامز، الكباسيتي سوري الكباسيتي للرام، سرعة السي بي يو. So instead of analyzing the algorithm based on the time, we need to analyze it based on the complexity. So before we start analyzing the algorithm based on the complexity, we would like to go through the process of structuring the algorithm. So we have two types of presentation or structures for algorithms. We can either represent the algorithm using flowchart, as you can see in this diagram, or we can write the code using pseudocode. And this is an English syntax. We can use simple English statements to describe the code and the functions. So we have two ways to consider while يعني writing the code and preparing the algorithm. So either we use the flowchart or we use the pseudocode. For programming purposes, and at the end of the design of any algorithm, you need to send this algorithm for a developer in order to write the proper code in one of the programming languages, whether it's Java or C++ or Python. So for easier understanding by the developer, it is must prefer to use the pseudocode. So pseudocode is much clearer for the developer to read the code and implement it. So it's a high level description of the algorithm. Okay, it's very clear because we are using English language. It doesn't require much space. See what's about the space here that the flowchart is taking, and see the space here that the pseudocode is taking. And we don't take care too much about the details. See, for example, input hours. We don't mention whether the hours is integer or string or whatever. It's very abstract. So we are hiding the details of the design. Now the complexity of any algorithm is measured by something we call it big O notation. Big O notation. We have three types of notations. We have big O, omega O, big O, big omega, and theta. O, omega, theta. We have three types of notations we are going to consider in our analysis. I'll go through it inshallah in more details. Now, what do you mean by the complexity? Let's say you have two functions, function fn and function gn. We say that the function fn is O of gn if there are positive constants c and nc, or sorry n0, such that gn multiplied by the constant c is greater than fn for all values of n greater than n0. What does this mean? It means that the growth of the complexity of gn is much bigger or equal to fn. So gn is always bigger than fn when it is multiplied by c constant for all values n that are greater than n0. So here in this example, you see that fn, see fn is, this is the dark black one, This is the Fn, the black line, and you can see here at this point starting from n0 and bigger number, yani more than n0. Now cgn start to grow up more, so gn is growing more than fn, so that's called fn is ogn, means the growing of fn is less than the growing of gn. This is an example. If you have a function which takes 2n plus 10, okay, later we will go in more details on how to find the 2n plus 10. Now just consider the example at this level. So 2n plus 10, here in this example we have the 2 and we have the 10. These are constant, okay, fixed number. هاي أرقام ثابتة ما بنهتم فيها. We just take care of the variable, and the variable here is n. So the whole function is O of n. We don't consider for the big O notation the constant. We don't say the function is O 2n plus 10. We don't care about the constant here. طيب. So if we say fn is O of gn, means the growth rate of gn is bigger than the growth rate of fn. So that means gn grows more fn, right? But gn is not less than fn, because this statement is incorrect. So gn grows more only in this case, fn grows more only in this case, and the same growth in both cases if both of fn and gn are equal. Because remember here we see here in this example, we see that gn is greater than or equal, which means at some point they might have the same growth rate. So we might come to a point where both of gn and fn have the same growth rate. When gn equal fn. And at this state, actually, this is the case where fn equal gn, when both of them at point n0. The other notations that we have is the big omega and big theta. Big omega and big theta. So for fn is omega of gn if there is a constant c is greater than 0, which means positive, and the constant n0 is greater than or equal to 1, which is also positive, such that fn is greater than gn. Greater than gn. But theta, and by the way, I will go to in more details about omega and theta. In theta, it is actually the average case. So here, fn is less than gn or equal gn and greater than or equal gn. What does this mean? Yani, what do we mean by saying this? What is the value of x in this example? X is greater or equal to 5, and at the same time x is less or equal 5. What does this mean? Exactly. Yes. يعني بحكي الاكس هي اكبر او يساوي 5 وبنفس الوقت اقل او يساوي 5، معناته هي 5. That's true. That is the theta. I will make it very easy for you. I know that it might be complicated now, but I will make it much easier for you to know the difference between big O, big omega, big theta. So in big O, have you how many students have finished the M180? Okay, good. Excellent. طيب. Let me let me give you a clue. What do we mean by big O, big omega? Okay, okay. Let me give you a clue. See, each algorithm, in order to find the complexity, we have to go through the code of the algorithm line by line. Okay, Lama, no problem. Let me give you a clue, even if it's not 100% clear for all of you. When I go in more details in later classes, you will know what I mean. See, uh, each algorithm, in order to be analyzed, we need to go through the code of the algorithm line by line, and we find the complexity of each line in the code. Some line of the code are executed one time. For example, when I say integer x, this line of code will be executed at constant time because is going to be executed only one time. So the time that this line is taking is actually 1. But when I write a for statement and I say, for example, for integer I is equal 0, I less than 10, I plus plus, how many times this for loop is going to be executed? Exactly. If I said less than 20, it will be 20. صح؟ طيب إذن if I say less than n, it will be n. So in this case, the for loop is going to take n time. It's going to be executed n times. So after going through the lines one by one, we can come up with an equation which can actually give us an overview about the overall performance. And usually the performance is the highest complexity, has the highest complexity. So for example, if the code has 10 lines, 5 lines are constant, which takes only constant C1. 4 lines takes n, and 1 line take n square. So the complexity of the whole algorithm is n square plus n plus 1. In total is n square. We will take the highest. Why? Because we are considering the worst case. No, we don't consider n to the power 3, n square, n to the power 2 يعني. روان. So why we are considering this? Because we are considering the worst case. So if you remember, each algorithm has a complexity starting from 1, and then we have n, and we have n log n, صح? And then we have square root of n, and we have the n square, and so on until we reach 2n, 2 to the power n. So after finding the complexity of the code, let's say that the complexity of the code was, let me find the color, okay, here, O n log n. Okay, this is the big O notation. So the code has a complexity n log n. This is big O notation. So this is actually, let me just give you here one example, change the color. So here, from this point, this is the n log n, including this group. This is called the upper bound. This is the upper bound. So the complexity of the code n log n, starting from n log n onward, this is called the upper bound. Okay, where is the lower bound? Starting from n log n back to 1 and n, this is called the lower bar. So here we have upper, here we have lower, and here is what? Average. Exactly. So for this algorithm, which has O n log n, O notation, big O notation is O n log n, the omega, the big omega of the code is what? No. Omega is the lower. Omega is the lower. No. It will be, as Safa said, n. It will be n. And the theta is the average. N log n, yes. N log n. Yes. This is just a general example. It not might be very accurate. I just want to show you what's the difference between the omega, theta, and the big O notation. So if let's say for example you have a code, a Python code or whatever language, and you have a print statement like hello algorithm. This is going to be executed one time only. So this function is gn equal 1. So it's a constant. See, it's a constant function. This is when we have linear. So the gn is taking n time, is going to be executed n time. See, for I in range O to n, print I, so it's going to be executed n times. So every time we move forward, the n is growing linearly. No, this is 0, 0, yes. 0. What do you mean by the override, Abdullah? I did not get your question, Abdullah. What do you mean by the override? No, riding, this is the override. We have a function call. So it depends on this function, how many times it's going to be executed. Yes, override is the same, yes. Same method. And same signature. طيب. So this is how the execution uh, estimation of the execution of this function. And then if we have another function here, see, we have the power of 2, this is another function. We have while statement, while statement. So while a is greater than 1, it will go through this direction, right? Else it will go through this direction. So we have two directions. One of them only is going to be executed. That's why the while and the if statement are going always to take log n. Log n, not n, log n. Both of if statement and while are going to be executed log n. Why? Because if you have a code which takes two or will lead you to one of the directions, so it's going to take log n. And this is how the log is moving. See, until some points the curve, actually the line is going to the curve, not going up like the linear. Here we have the n log n. Actually it looks like the opposite. See, this is how it looks, the log n. The n log n will change the curve. It is more closer to the n. It's closer to the n. And when do we need, or when do we have the n log n? When do we have n log n? If you have while that is inside for loop. This is a while inside the for loop. So the for loop here is executed n times, and the while here is executed log n. So the total is n log n. You got it? How we calculate the numbers? Sorry, we evaluate the performance. Excellent. Okay, in this function we have two for loops. They are nested loops. So this one is going to take n, and this is another n. So the total will be n square, because this one is going to be repeated n by n. So it's n square. And this is actually the series which is actually used to prove the n square. Any question? Yes. No, actually this is just an explanation on how we get the n square based on this series. Okay. Now n to the power 3. See, here we have 3 for loops. 1, 2, and 3. 3 for loops. We are going to execute this code which is inside 3 nested loops. So this one is going to be repeated n times. This is n by n, and this is n by n by n. Yes, Yasser? What's the problem? The print statement, you mean where? In this code? Yes. Of course. This is actually the time, the n square, sorry, n to the power 3. It is actually the time going to be considered for this statement, for the print I multiplied by j. It's going to be repeated n by n by n. We don't consider only the for loop, we are considering the code inside the for loop, not only the for loop itself. You got it? طيب, let me give you this example. I will write it for you. ايش رايكم بالكود؟ What is the complexity of this code? لا فاطمة, we don't consider ال constant. يعني we don't write divided by 2 or multiply by 2. عبد الرحمن, this code, you can see the code even? This code. I want you to write not only the general answer. I want you to write يعني how you find n square or n to the power 3, how you found it. I think there is something that you have not noticed, and that's why I write this example. See the second loop. The second loop is for j in range 0 n divided by 2. What does this mean? Means what? It doesn't matter. أيوة, half of n. Yes, Sonia. No, 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 Rawan, that's not correct. It's not always n. That's why I write this example. It's not always n. For loop is not always n. I will provide you after the class. I will provide you with another set of examples which clearly show you, especially those who have covered the M180. They are very aware. They're supposed to be very aware of this issue, if they do remember it. Aywa, not all for loops takes n. Remember this. See here, n in the second for loop, it's going through all the numbers in up to n divided by 2, means half of the list. It's only half of the list. So which means the second for loop will take only log n. And here the first one will be considered as n. So the total for print I is to be n log n. So be careful while analyzing the algorithms. For loop are not always n. I know it was like very easy for you. Everybody is going, yani, are answering the questions easily. But I have to highlight this one because I know that some of you are not aware that it's not always n for loops and loops in general. Why, Lama? Why? What's the problem? Why you get confused? No, I did not remove the n. I said that we haven't go through all values of n. Only half of them. Okay, do you remember the if statement? What did I say for the if statement? What is the complexity of if statement? The if statement, sorry. Aywa, it's if else. So only one of the direction. That's why in while loop, let's go back to the while loop. See here. See. See, in while loop, we did not consider it as n, even though while is a loop, but we consider only n log n because either one of the lines is going to be executed, the second one is no. So here is another form of what? Of division. We are dividing the code into two halves. Exactly. Yes, Rawan. Yes. Okay, excellent. Okay, this code. Why this code is 2 to the power n. If n equals 0, we return 0. If n equal 1, return 1. Else return fn minus 1 plus fn minus 2. Why do you think this code is going to take 2 to the power n? It looks very complicated. Here we have 1, 1, 1, 1, and here we don't know what's happening. Suddenly we have 2 to the power n. Why? What's wrong with this statement which make the performance takes 2 to the power n, or the complexity? What is this? No, no, no. أيوة صفا. أيوة. So what kind of calling the function? Yes, but which function we are calling here? No. Yes. Okay, calling the function f, right? Same function. So what we call this process? When the function call itself, we call it what? Exactly, Abdul Hakim. Recursion. This is a recursive function. Recursive function take 2 to the power n. Take 2 to the power n. Yes, when the function call itself, it's 2 to the power n. So if you want to sort the algorithm from the best in terms of complexity into the worst, that is the from up to bottom. This is the best when we have only constant. Then we have the log n, n log n square, n to the power 3 cubic, and exponential. Now I want you to know another fact. If, let's say, we found a function, the complexity of the function is O n log n, okay? Can we say that the complexity of the same function is O n square? Can we say this? Yani after we analyze one algorithm, we found that it is O n log n. Can we say it's O n square? Please give me 2 minutes. I answer the call until you find the answer. As I said, when we classify the performance or the complexity of the algorithm, the best is when we have constant time, like 1 or 2 or 3, whatever numbers, and going to log n. This is the second one. Third is n log n square, n to the power 3 cubic, and exponential 2 to the power n. So the more you go down from up to bottom, it means the complexity is higher. So the time complexity, the complexity of the algorithm become worse and worse. For example, we have here in this example the performance or the complexity of two sorting algorithms. We have the merge sort and the insertion sort, two algorithms. The complexity of the insertion sort is n square divided by 4, and the merge sort is found to be 2n log n. If we have 1 million items, for example, 1 million items, the insertion sort will take 70 hours to finish sorting the numbers. But the merge sort will take only 40 seconds. Okay, 40 seconds. This is actually the result for very low or slow machine. Of course, if you have faster machine, the numbers will be much less. So what we can see here, if you look at the behavior of the two algorithms, the red one is the merge sort, and the blue one is the insertion sort. Until we reach this point, see this point here, when the number of element is around 100, okay, when it is around 100, the performance the performance of the insertion sort is much better than the merge sort. It's better than the merge sort. But starting from the point 100, when we have more than 100 element, the performance of the insertion sort become worse and worse. So we cannot say that merge sort is better than insertion sort, and we cannot say insertion sort is better than merge sort. It all depends on the size and the number of elements that we are going to sort. You get the point? Yeah, it's faster when we have less element. Once we have more elements, the merge sort become much better. So why we don't consider a yes, Amjad, depends on the size of the element. Yes, exactly. So constant time, actually, it's related to many factors. That's why we don't consider the constant C in our evaluation as a big O notation. It might be related to actually the operating system. It might be related to the capacity of the RAM, the speed of the processor, how many tasks you are running now on your machine. So many factors are actually affecting the constant. That's why we consider it as a constant, but we don't consider it in our big O notation. And as I told you before, all type of statements in programming are not going to be considered as constant, except if that statement is going to be executed once. Any statement in the code is going to be executed one time, it will take constant time, C. That's why we don't write 1 or 2 or 3. We write C as a constant. Okay. Now, this is a function. It's called prefix average 1, which take an argument S. Look at this code. This is actually very bad design of the code. This function has one for loop, okay, and has the total here. Another for loop, so this is a nested loop. It will consider the total plus equal si, which means total equal total plus si, and then aj equal t1. Actually, total divided by j1. So what we care about here is this line of code. Okay? How many times we are going to loop through this line? And this line also. This line and this line. No. No. أيوة. See this line? This is a nested loop. No, wait. This is a loop, and this is another loop. So this one is going to be executed n by n, because we have nested loop. So this is n to the power 2. Don't forget this, please. This is how we analyze the code. Type. That's why actually it's very important for you as a programmer to find the suitable code and implement the function in its best way with the best performance, because I might give you a problem and I ask, now we have in this class 57 students. I'll give the same problem for the 57, or now there are 56 students. Each one of you will give me different solution. I cannot say that all of them are the same. One of you or group of students will give me the best solution, the less complex solution. So in order to just to judge which one is the best, you have to be able to analyze the complexity of the code, similar to the way that I'm doing now. So here we have this line is going to be executed n to the power n, n to the power 2. Now they work on the code trying to find a better way, so they come up with this average prefix average 2 code. Instead of having two nested loop, they come up actually with a same one line. They take out the nested loop. We have only one loop. Fine. But the problem now, we have another call. We are calling another function, which is sum. So again, the for loop will be executed n times, and the function n will be executed n times. So again we have n to the power 2. So that is little bit better, but the same complexity. It has the same complexity. Right. They work on the code again. They try to make it better. What happened here? We have only one for loop. Okay. They find the total plus equal sj, and then aj equal total divided by I. So this code is going to be executed n times. N times, and this one n times. So it is n plus n, because this is two statements within the for loop. So n plus n equal n. So the big O notation of this code is O of n. So it is O n. Yes, 2n. But because we don't consider the constant, we cannot say O of 2n. We say O of n. Okay. Here are some activities for you. Please do it at home. Try to analyze the code. Very simple. And this is another one. Try to analyze it as well. That's very simple for you. If you have any issue, yes, Ibrahim. If you have any issue with the codes, we can discuss it inshallah in our next class. Type. Until this point, do you have any question? Fine. So I will. By this, we are finishing this meeting with the second meeting.